Hello everyone, in this video I'm going to explain questions from past paper about stationary waves. Let us see this question. So we have the distance between the oscillator and the point B is L. He said points X and Y are 2 points on the string. So this is point X and this is point Y. The distance between point X is a distance 1 over 8L, and also the point Y 1 over 8L from P. Point Y is okay. For the vibrations of point Y, then we talk about the point Y, state the frequency in terms of F. So the point X vibrates with frequency F. This is the incident wave. So it is the same frequency for incident and reflected. So for the vibrations of the point Y, state the frequency in terms of F. It is the same as frequency of the point X. So it is also F. The amplitude in terms of A. He said the point X is of amplitude A. So what is the amplitude of the point X? That. So this is the equilibrium position. So this is the amplitude of the point X, which is A. Because the point X has the same distance of the point Y from the end, so the amplitude of the point Y is the same as amplitude of the point X. So the amplitude of the point Y is also A. Now we complete that question. State the phase difference between the vibrations of point X and Y. The point X here and the point Y is down. Look, this is vibrate up and this vibrates down. So the phase difference is pi. They are anti-phase. So the phase difference between X and Y is pi radian. State in terms of F and L the speed of the wave. This equals L. So the wavelength, because this is half lambda, this is naught and this naught, so this is half lambda, and this naught and this naught, this is half lambda. So one complete lambda equals L. So lambda equals L. What is the speed of wave? We know that the speed of wave equals lambda multiply the frequency. Now lambda in that question equals L. So the speed is L multiply F. He said the wave on the string is stationary. Explain by reference to the formation of a stationary wave. Formation of a stationary wave. What is meant by speed stated in part I? This is incident wave. So the incident wave and reflected wave, so this is incident and this is reflected wave, interfere. So the speed is the speed of incident wave or the speed of reflected wave. So the speed in a stationary wave, he said, explains, okay, what is meant by the speed in part I? The speed is the speed of incident wave or reflected wave. So the wave is reflected at the point B. The wave reflected at the point B. Incident wave and reflected wave interfere. So the speed is the speed of incident or reflected wave. Now we solve another question from past paper. In that question, he said a string is stretched. Okay, so the length between that two nodes is 75 centimeter. So half lambda equals, so we know that the distance between two successive nodes is half lambda. So half lambda equals 75 centimeter. So lambda equals 2 multiply 75, it's 150 centimeter. State the wavelength. So the wavelength is 150 centimeter. When we convert it to meter divided by 100, it's 1.50 meter. So this is the wavelength. The frequency of vibration of a string is, so we have F. F equals 360 hertz. Calculate the speed. We know that the speed equals lambda multiplied by F. Lambda is 1.50 and the frequency is 360. So the answer is 540. What is the unit? Meter per second. By reference to the formation of stationary of the stationary wave on the explain what is the meant by the speed in part B. So the progressive wave reflected at the fixed. This is the progressive wave reflected at the fixed end. Wave is formed by superposition of the two traveling waves. This quantity is the speed of the traveling wave. So, progressive wave reflected at the fixed point, the fixed ends. Wave is formed by superposition of the two traveling waves. This is incident and this is the reflected wave. So this quantity is the speed of traveling wave. I hope you understand this lesson. Thank you.